Good evening, students. Welcome back to our session. So, due to some network issues and some technical issues, so I'm just restarting the session here. So, yeah. So today we'll just continue and the topic of trigonometry. So if you guys go back and see my before two sessions which I have already done in this particular topic of trigonometry. So those two sessions actually give you a very introduction to our trigonometry, and so the major question is why I have actually picked this particular chapter. Because you have actually just finished your 10th standard and now you guys are entering into your 11th standard, isn't it? So I thought of if I start with a topic which is quite familiar to you, so it will be easy for you to grasp it, right? So that's why today we are going to see this topic of trigonometry. So in the first session of trigonometry, I have clearly explained you what and all topics you have learned in your 10th standard and what you are going to learn so what you are going to learn in your 11th and 12th standard in regard of this particular topic of trigonometry, right? Okay, I think now it's audible for you, so there is no stuck or buffering in the audio or video, I guess, right? So we'll just continue with the session. Yeah, so as of now 2 sessions are already over. So in this, to begin with our today's session, first what I'll do is I'll just give a quick overview of what we have covered in our previous sessions of trigonometry, and now in this particular session what are the concepts we are going to cover, which means what are the new concepts you are going to learn in regard of this particular topic of trigonometry, right? So basic identities. So this basic identities, if I keep it in this way, you guys have already learned in your 10th standard. So let me take an example here. So cos square theta plus sin square theta is equal to 1. So I guess you all have noticed this particular identity. You guys are familiar with this particular identity. Cos square theta plus sin square theta is equal to 1, right? So we have even the identities for our cosecant theta, secant theta, tan theta and cot theta. So these typical basic identities we have covered in our previous sessions, and along with that we have even covered the concept of sign of trigonometric functions. So now I am going to keep it in this way. This sign of trigonometric functions is actually very important in our trigonometry. Why? Generally, if I say something is important, the first question which will get into your mind is why this is actually important, isn't it? So the reason why this sign of trigonometric functions is very important, because it's like to solve a very small question to a very huge one or the other, we'll getting into this particular concept of sign of trigonometric functions. So where we'll be using this. So not only in this trigonometry, we are going to use this sign of trigonometric functions in our inverse trigonometric functions. So this particular chapter you will be learning in your 12th standard. So even in that chapter you have to use this sign of trigonometric functions, right? So now what this sign of trigonometric function states. So what is this actually? So if you have gone through my previous sessions, you might have already known it. What is this sign of trigonometric functions? So to keep it in simple words, I can even say it as a quadrant system of trigonometric ratios. Have you guys heard about quadrant system? Okay, or else you might have heard about this particular sentence, that is all silver teacups. Maybe in your schools, in any of your sir or else any of your book, you might have seen this typical sentence, all silver teacups, right? So why we actually use this typical sentence? To make it remember our signs of trigonometric functions in an easier way, right? So let me show you that particular quadrant system. So as we all know what is x-axis and y-axis, so this will be our x-axis, this will be our y-axis. So this will be my first quadrant and this will be my second quadrant, this will be my third quadrant and this will be my fourth quadrant. Let me know guys. Yeah. Okay. Sorry. Yeah. So this is our quadrant system. So 1, 2, 3, 4. So for this particular quadrant system, to remember our signs of trigonometric functions in an easier way, we'll just follow this general statement called all silver teacups. Right. So first letters of each of the word represents our trigonometric functions. So all. So this is our A. So in first quadrant, A in the sense all our 6 trigonometric functions will be positive in the first quadrant, right? And then the next first letter of the word is S, that is silver. This S represents our sine function as well as our cosecant function, which states that the sine function as well as the cosecant function will be positive in our second quadrant, and the third word will be teacups, so T. So this T represents tan theta as well as cot, which states that our trigonometric function tan and cot will be positive in the third quadrant. And the last word is nothing but cups, which stands for our trigonometric function cos as well as secant, right? So which states that the trigonometric functions cos and secant will be positive in the fourth quadrant, right? So to remember all these functions, like in which particular quadrant which function is positive, so to remember in a easiest way, we'll just use this simple sentence called all silver teacups, right? So this is all about our sign of trigonometric functions. So I am not going in deep because I have already covered this in our previous sessions, so please just go through that. Yeah, so apart from that, the next topic we have covered is transformation of trigonometric functions, right? So this is also related to our quadrant system. So one trigonometric function will be transformed to another trigonometric functions at certain conditions, right? So that we have covered, right? So coming to our today's session, we'll be beginning with the specific values of trigonometric functions. So if we take some specific angles, so for that corresponding value, for that corresponding angle, we'll be having specific values. So now you might have a question like why we are actually starting with this typical specific values of trigonometric functions. So there is actually a reason why I am starting with this specific values, because once we know the specific values of trigonometric functions, this will lead us to plot our graphs of trigonometric functions. So the next concept of our today's session is graphs of trigonometric functions, right? So to plot any of the graph, so if we are having a function, if we want to plot any of the graph, we should know the values of our x-axis as well as y-axis, isn't it? So to get the values, we should know the specific values. So if it is some random x and y, we know the values, isn't it? If for example I am having y is equal to x plus 1, so you have to plot the graph of this. So if you take some x value 0, then your y will be automatically 1, right? So for the similar way, for trigonometric functions, we should have some specific values. So using that only we can predict our graphs of our trigonometric functions. So that's why we'll start with our specific values of trigonometric functions, and then using that we'll be plotting our graphs of trigonometric functions. So once we are done with our graphs, the next topic of our session is nothing but discussing the properties or identities. So these properties are different from the basic identities which you have learnt before or else in our previous sessions. Right, so these properties here which we are going to see are quite new for you guys. So these are our new properties, new identities which you are going to learn in this session. Right, so without a delay, we'll just start with our first topic of our today's session, that is specific values of trigonometric functions. So to make it in an easier way, I just kept all this in a typical tabular form. So what and all angles I am taking here. So here I am taking 5 angles which are given by 0 degrees, 30 degrees, 45 degrees, 60 degrees as well as 90 degrees. So these are the 5 angles I have taken here. So and we are considering all our 6 trigonometric functions. So sin theta, cos theta, tan theta, cot theta, secant as well as cosecant theta. So now we'll begin with our sin theta first. So here sin theta, so we are starting with 0 degrees. So sin 0. Right, so first we'll try to fill up the specific values for our sine trigonometric functions, and then I'll just tell you using that particular values how can we actually write our specific values for the remaining 5 trigonometric functions. So the first one here we are going to see is for sin theta. So sin 0 degrees. So sin 0 will be 0. And sin 30 degrees will be equal to 1 by 2. And sin 45 degrees will be equal to 1 by root 2. And sin 30 degrees, 60 degrees will be equal to root 3 by 2. And sin 90 degrees will be equal to 1. So as I told you, first we have filled up our first row, which is nothing but our values of sine function. So now we'll just get into our next step, cos. So now how can we write the values for our cos function? So for cos function, it is nothing but simply writing from the backward of our sine. So here it is, the last one is 1. So sine 90 is 1. So that will be coming here. So it will be 1 here. And the last but one, root 3 by 2. So here it is root 3 by 2. And here same 1. So it will be 1 by root 2. And here it will be 1 by 2. And here it will be 0. So to get the values of our cos trigonometric functions, what we have done here, simply taken the values from the back side of our sine function. So now to get the values for our tan trigonometric function. So if you guys see our previous sessions, there I have given you a slide in which you see the relationship between the trigonometric functions. So using that, our tan can actually written as sin theta by cos theta. So from the above you can find that we already have our values for sine function as well as the cos function, isn't it? So now tan theta is nothing but sin theta by cos theta. So now here it will be the first one. So tan 0 degrees is nothing but equal to sin 0 by cos 0, which means 0 by 1 will be 0. And here 1 by 2 by root 3 by 2 will be 1 by root 3. And 1 by 2 by 1 by root 2 by 1 by root 2 equal to 1. And here it will be root 3. And here if you observe, it will be 1 by 0. So 1 by 0 is nothing but infinity. And the next trigonometric function is cot. So cot can be written as 1 by tan theta. Right, so reversal of it. So 1 by 0, it will be infinity. So 1 by root 3 will be root 3. And 1 by 1 here will be 1. And here it is root 3. So 1 by root 3. And here if you observe 1 by infinity. So 1 by infinity is nothing but equal to 0. So if we observe what we have done here, so only taking the first sine function values. So sine function values you have to remember. So using that we have written the cos, and the next we have written our tan function values, and the next we have written our cot. So now let's write our next function, that is secant theta. So our secant theta as having relationship with our cos function. So secant theta can be written as 1 by cos theta. Right. So now we'll just compare to our cos theta. So secant 0 degrees will be equal to 1 by cos 0. So 1 by 1 will be 1, and here it will be 2 by root 3. Here it will be 1 by root 2. 1 by root 2 will be root 2, and here it will be 2. And here secant 90 is nothing but 1 by cos 90, and cos 90 is 0. So here it will be equal to infinity. Right. So this is our secant theta specific values. And the last trigonometric function we are having here is cosecant theta. And the cosecant theta here will be having the relationship with respect to our sine trigonometric function, where our cosecant theta will be equal to 1 by sine theta. Right. So now again 1 by 0. So 1 by 0 will be infinity. So 1 by 2 is nothing but equal to 2. And here 1 by root 2 will be equal to root 2. And here 1 by root 3 by 2. So it will be 2 by root 3. And here 1 by 1 will be equal to 1. So now we have finished our tabular form. So here you can see we have written all our specific values for our trigonometric ratios. Right. So here we have considered only 5 angles: 0 degrees, 30 degrees, 45, 60 and 90. So why I have considered only these 5? So using only these 5 values as well as relating with our quadrant system, you can find any other values of any other specific values of the trigonometric ratios. So that you will be learning, so that you will be seeing when we solve some questions. So in our further of this session, we will be doing few questions where you might understand how we will be using our specific functions, using our specific values. Right. Right. So if I am taking some x values and substituting here, then you end up having your corresponding y values, so that you can plot the graph easily here. Right. So you can take a start from 0. So generally we'll start from 0. So I am just taking it to be a 0. So sine 0. So what is the corresponding value we have seen? So sine 0 degrees is nothing but 0. So when x value is 0, y value is also 0. So that you can say that will be our first point which we have plotted here, isn't it? So similarly, if you have seen our sine 90. So sine 90, so let me take x value to be 90. So in radian it will be pi by 2. So if I substitute sine pi by 2, so sine pi by 2, sine 9 space. Right. So if you observe, using our standard specific values which we have seen in our previous slide, we just plotted the graph. So the graph of the sine trigonometric function will look something like this. So before getting into our next graph, let me tell you one thing. So here in this graph, so now we are only concentrating our graph, how we are actually plotting that using our specific values. But in future, you will be seeing a chapter called Relations and Functions. So there you will cross a topic called Domain and Range. Right. So when we are discussing our relations and functions, so there we'll again get into our trigonometric chapter, where we'll talk about our graphs of trigonometric functions in the context of domain and range. Right. So for now, we'll just see how we are using our values to plot our graph. That will be enough. So while we are discussing our relations and functions, we'll talk about in the context of domain and range. Right. So moving forward, so the next trigonometric function here is y is equal to cos x. So the next function which I am going to plot here is y is equal to cos x. So for this function, the same value, same typical way, if x is equal to 0, y will be 1. That means half. Right. But the only condition, only difference we can see here is when our for cos it will be 0 comma 1 point, and for sine it will be 0 comma 0. Right, so this is our shape of the graph of our trigonometric function cos secant. So this is what we are going to see for the function y is equal to tan x. Right. So for this function, if you observe in the specific values which we got, we actually seen the infinity there. So again we will be seeing the infinity while plotting our graph. Right. So if you observe here, our tan 0 will be 0, which means 0 comma 0 will be 1 point, but our tan 90 is infinity. So we'll be having a point called pi by 2 comma infinity. So how can we actually plot this graph pi by 2 comma infinity? So that is nothing but, so this is our pi by 2 on x-axis, but in y-axis it will never touch because it's a infinity here. So that's why the shape of the graph of our tan function will look something like this. Right, so this is how it will be having the graph for our trigonometric function tan. Right, because we are having infinity for our tan function. So in the same typical way, even for our cot x. So the next function is our cot function. So y is equal to cot x. Right, so for this function, we are having a point 0 comma infinity. Because our cos 0 degrees is nothing but equal to infinity. So we will be having a point 0 comma infinity. So how can we plot this point here? So the plot here will look something like this. Because if you observe, for both going to see is of the function secant. So here we are having a function y is equal to secant x. Right. So the same thing here, even for secant, if you remember, secant pi by 2 is nothing but equal to infinity, which means at the value of x is equal to pi by 2, we are getting the y value to be infinity, which is pi by 2 comma infinity. So here is one of the point which we have to locate, which is given, which is in terms of our infinity. So that's why for pi by 2 you could see the plot here, it is infinity, it's going like this. But our secant 0 will be 1, so that's why we are having one more point here, that is 0 comma 1. So our plot will be something like this. Right. So if you observe, okay, let me see the last function and then we'll just compare our graphs of each of the trigonometric functions. So this is our last plot, cosecant. So y is equal to cosecant x. So this is our last function, cosecant function. So let's see the points here. So cosecant 0 will be infinity. So we are having a point 0 comma infinity, and cosecant pi by 2 will be 1. So these are the standard points, we can say 0 comma infinity and pi by 2 comma 1. Right. So this is how you will be having the plot of the cosecant function. So if you guys remember and consider all the graphs of our 6 trigonometric functions, the shape is actually, the shape of the sine and cos functions are quite similar to each other. Similarly, tan and cot are also somewhat similar to each other, and in the same way secant and cosecant. So it's like we are just taking a what we can say conclusion, typical conclusion, or our observations after plotting the graphs of all 6 trigonometric functions. Right. So but now I am only talking in terms of our graphs which is related only to the specific values. As I have told you, when we are dealing with the chapter of relations and functions, I will be again talking about the graphs of trigonometric functions, but in a different point of view, which is in context of domain and range. Right. So now you have seen the specific values and how we are plotting the graphs. So now let's do a question which is related to our values as well as our quadrant system. So let's do a question here. So I think you might have aware of how to solve these typical kind of questions. So here you have to find the value of cos of minus 1710 degrees. So here's the question goes. So you have to find the value here. Right, so you can use your properties, you have to use your the values, and you have to even use your quadrant system here to find the to find the value of the given cos function. So just take 2 minutes of time and just give it a try by your own, and then I'll explain you. So find the value here. So find the value of the given function. So to keep it in simple way, I'll just show you the quadrant system here. And you have to keep in mind in terms of the transformation also here. So this is 0 degrees, here it is 90 degrees, and here it is 180 degrees, and here it is 270, and after completing a single revolution it will be 360 degrees here. So if you have done solving the question, please let me know, guys. Please text me the answer, so that if anyone is facing any difficulty in solving the question, please let me know, so that I can explain you the solution, as well as I'll just help you with solving the question. So has anyone given a try to solve this question? So you have to actually rewrite this typical angle such a way that you have to get your value which is included with your quadrant system. So first you can see this is nearer to which of the multiple of your angles. So you can take 360 or 180 or 90 and 270 and check multiple of it, and which is nearer to this given angle 1710 degrees. So that we can actually rewrite this angle and we can find the value of it. Has anyone solved the question? I haven't received any message from you guys. I'm not sure whether you have solved it or not. No. I'll give you one more minute so that you can give it a try, or else I'll just explain you the solution here. Is anyone there? Arun? I guess Arun and Jayanand and Alan are there. So please give it a try for the question and let me know. Okay. Have you solved the question, Arun? Minus 19 by 4. So how you got minus 19 by 4? Okay, Sanjay also there. Okay. How you got minus 19 by 4? Okay, let me keep it this way. First, I'll explain you this question so that you should know how we are actually using the quadrant system and as well as our specific values. Right. So if you observe, it is a huge number. It is in terms of thousands. So I'm assuming it is somewhere nearer to a multiple of 360. So I am trying with 360 times 4. So it is 14. So I'll go with 5 times. So 30. So 1800. So if you observe, the difference between our angle 1800 and 1710 is nothing but only 90 degrees. Right. So now what I'll do, cos of minus 1710. So cos of there is a property. If you have gone through my first sessions, you will be seeing this. So cos of minus theta will always be equal to cos theta. So here cos of minus 1710 degrees will be equal to cos 1710 degrees. So now what I am doing is I am rewriting this 1710 degrees as cos of 1800 minus 90 degrees. So this is nothing but again 1710. So this 1800 can be written as cos of, which is multiple of 5, right? So 5 times 360 degrees minus 90 degrees. So what this actually phi means here? So what does this phi indicates here? So the phi actually indicates that we end up having this angle after doing a complete 5 revolutions. Right, so that's what the phi here meant. Right, so that's why no need to worry of it. It actually resembles the number of revolutions. So we have replaced our 1800 with 5 times 360 degrees. Right, so now we are having cos of 5 times. Okay, let me erase this. Sorry. So now we are having cos of 5 times 360 degrees minus 90 degrees. So now it is revolution, so no need to worry. So here we have to check in terms of our quadrant system, that is 360 degrees minus 90 degrees. So we'll be having a quadrant here 360. So if we are going ahead means here it will be 360 plus theta in first quadrant, but it is 360 minus, which means it will be lying in fourth quadrant. So for fourth quadrant, our cos function is positive. Right, so all silver teacups, if you guys remember. So see, in fourth quadrant, it will be positive. So our cos function will be positive here, which means positive. So the value will be positive. Right. So now here we have to check whether there will be transformation of our trigonometric function or not. So how we will be seeing that? So I have already explained you this typical quadrant system clearly in previous sessions. So if you have anything in multiples of 180 or 360, then there will be no transformation. So here it is multiple of 360 here. So there is no transformation. So cos function will remain as it is and theta is 90 degrees here. So plus cos 90. So cos 90 is nothing but equal to 0. right? So the angle which we have seen for our cos 90 is 0. So now you might have understood our relation between our quadrant system as well as our usage of specific values. Right, so this is one of the typical question in terms of degrees. So I have explained you here clearly. So now I will be giving you one more question. So you just give it a try. So here is the next question. So here the angle they have given is in radians. So there is no need to worry. You know that 180 degrees is nothing but equal to pi. 90 degrees is nothing but equal to pi by 2. 30 degrees is nothing but pi by 6. 60 degrees is nothing but pi by 3. And 360 degrees will be equal to 2 pi. So these are the relations or conversions of our degree and radians. So now you just give it a try for this question and let me know what is the value of this. Okay, I guess Arun, you have given 0, that's correct only. Just check it once. At last you have given it is 1. So the answer is to be 0 because our sin 90 will be 1. So cos 90 will be absolutely 0. So now just give it a try for the second question here. So if you have finished this one, please let me know what's the answer here. Okay. Solve the second one. So same way, but the difference here is initial one I have given in terms of degrees, but now I have given my angle in terms of radians. Okay, just give it a try for this. So you can directly same way how we have written 1710 in terms of another in terms of multiples of 360 or something like that. So even you can convert this in terms of multiples of any of the pi. So can you check, is it minus or plus root 3 by 2, Arun? The value is correct, root 3 by 2. So can you check whether it's plus root 3 by 2 or minus root 3 by 2? It should be minus only, right? So it will be in third quadrant, I guess. Correct. Okay. So you might have written as 10 pi plus pi by 3, I guess. Yeah. So sine of 10 pi plus pi by 3. So it is multiple of pi. So there is no transformation. So 10 pi in the sense pi will be here. So it will be in third quadrant. So negative. So minus sine pi by 3, which is equal to minus root 3 by 2. Correct. So now I guess you are you have understood how to use our quadrant system as well as our specific values. So there is one more question here which is quite related to our values as well as our quadrant system. So this question is actually one of the JEE mains question. So as we have started with our very basic level, so now I am jumping into our JEE level of questions. So this is one of the question in our previous JEE papers. So just give it a try for this question. So this is also in the same manner. We will be using here our quadrant system as well as our specific values. So you have to find the value. So you can see the question. This is all product, which means tan. Okay, you are talking about previous question. Okay, so here if you observe, our 31 pi by 3 has been written as 10 pi plus pi by 3, isn't it or not? Because it will be 30 plus 1, so 31 pi by 3. Right, so we have replaced our 31 pi by 3 as 10 pi plus pi by 3. So while converting, what we have to check? First we have to check the sign, and then we have to check whether there is a transformation exist or not. So first we'll go with our sign. So to get to know our sign, we have to check in which quadrant this angle lies. Right. So here it is 0, 90 means pi by 2, 180 means pi, and here it is 2 pi, and here it is 2 pi by 3, 3 pi by 2. So here it is 10 into pi, right? So which means multiple of our pi. We have written in terms of multiple of our pi, so that's why we got it to be negative. Sorry, I have missed here. It should be positive. Sorry. It should be 10 pi, right? So it is in terms of our 360. Right, so 360 plus means it will be in the first quadrant. Sorry, I have missed it. I have thought it is an odd number. It is 10 pi. Yeah, it should be 10 pi plus pi by 3, which means it is in terms of 5 times 2 pi. That is 360. So 360 plus pi by 3, in the sense it will be in the first quadrant. All will be positive. So sin pi by 3, which is equal to root 3 by 2. Sorry ma, I just missed the sign. I have considered it to be 11 pi. Sorry, I haven't seen 10. Okay, fine. It should be positive. So, has anyone tried? Okay, we'll just get back to our next question. Has anyone tried? Okay, Arun has given the answer. 1 correct. So now you can try the third question, Helen. Okay, Arun has given the answer 1. Yeah, it's correct. So I'll just clear one issue here. The major mistakes what we'll do is whether we have to write in terms of 360 or 180. So that's the priority, right? So first we'll check for 360. If not, we'll be checking with our 180. That means the confusion here, it will be if it is even number, then you can directly go to 360 degrees, that is 2 pi. if it is in terms of odd number, right, that means here it is 10 pi. 10 pi is a even. Then you can go to your 360 degrees. If in case it is 9 pi, which is a odd, then you can go to your 180 degrees. Right. So you have to see even or odd. Right. So that's why I have missed in the previous one. I thought here it is 11 pi. So that's why I have directly taken it to be pi, because we'll be considering here odd for pi and even for 2 pi when we are talking in terms of our revolutions. Right. So just keep this in mind. So this is a general mistake all will do. Okay. So yeah, Jainath and Sanjay, yeah, Alain, Arun. So all of you has answered the third question. Yeah, it's correct. So the answer here will be equal to 1. So as all of you solved, we'll just get into our next question here. So this is the question. It's like a typical proof question I am going to giving you here, because till now we are doing related to our, what we'll say, our specific values and quadrant system. So now we'll just do a question which is based on our basic identities. So even in JEE you can get this typical kind of question based on your basic identities. There you might they might not give you the RHS side, right? Or else you can expect this type of question either in assertion kind of thing, or else there will be assertion and reasoning questions, right? So in that particular section also you can expect a question related to basic identities, or else you can expect a question even in the normal MCQs where the RHS is not given, which will be given in terms of options. So give it a try for this question. And let me know whether you have proved or not. If you guys are able to prove it, then it's good enough. If not, I'll just explain you guys. So has anyone tried the question? So here you have to show two ways of proving. So the first one here is 1 by sine square a cos square a minus 2. So this is one approach, and the second one is secant square a into cosecant square a minus 2. So that is the second approach. Having the addition, so simply take the LCM and start adding the given. Okay, Jainath has told he has proved. Okay. Have you proved both the conditions? What about others? Are you guys trying? Sanjay and Alan and Arun? Okay, Sanjay also proved. So what about the remaining? Alan and Arun, have you guys tried? So we'll just wait for 1 more minute and then we'll just, okay, Arun also done. Okay, so I guess Ellen also almost, he might have finished. Okay, we'll just start with the formula here. So I guess we are left with 5 minutes. Okay, so we'll just start our next part. So the next part will be our formulas. So as I have told you in the previous or else in your lower section in your 10th standard or else your previous sessions, we have seen a very basic identities. So which you have used for this previous question to solve this previous question, right? So here we are having some more formulas for our trigonometric functions. So these typical formulas you are going to use mostly in your 11th and 12th standard, right? So the first formula here you can see is first sine of a plus b. So if you could see the LHS sign of a plus b, so the RHS for this will be sine a cos b plus cos a sine b, right? Yeah, Ellen also finished the previous question. Good. So now you can focus on the formulas here. So before getting into the formulas, let me tell you this. So trigonometry is nothing but huge number of formulas, identities, and you have to do lots of questions to get a good grasp over the trigonometric functions topic, right? Because if you could see this previous example, so here they have given the proof. That's why you know how to approach it and you have solved it. If it's a multiple choice question, right, then you should have your own idea, right? So if you have started with some other procedure and you end up getting in this, then it will be, if there is no option like this, which means you have to get in this way. So in that way you actually get a time measurement there, right? So you actually get a, like, we are actually repeating the same question, doing it again, isn't it? So to avoid those, we can actually go through all our identities and we have to see our options first. Then we might have an idea, okay, this is the step how we have to start. Because for trigonometry, there is no exact one typical answer, right? So for this proof kind of question only you can take it. So for this, there are two RHS, which means there is no one exact answer here, right? So that's why for trigonometry, what I'll say for you guys is, you should be thorough with all the formulas, identities and everything. So what we'll do is, so we have just finished our graphs and all. So I'll just keep this formula for our next session of trigonometric functions. So from our next session, we'll be starting all our basic formulas and identities. So what you guys do is, you just take all those formulas and identities in a sheet and you just go through them, give it a glance at least once a day, so that you might not forget those formulas and it may not be difficult for you to judge like which procedure you have to go, which formula you have to use, right? So with this, I'll just wind up our today's session. So in our next session, I'll start with the basic formula in this trigonometric functions. So I think today's class got a bit network issue. So I'll just make sure it doesn't happen from our next session. So you just, if you haven't gone through my previous two sessions on trigonometric functions, please go through those two sessions. So we'll just continue our trigonometric functions in our next session.